So very good morning. Today will continuation of the routing protocol of Adhoc networks. We'll see about DSDV protocol. It is called as destination sequence distance vector routing protocol. It works based on the proactive distance vector algorithm. As we have seen in the previous videos about the routing table algorithms, routing algorithms, two types are there. One is a distance vector algorithm and the other one is the link state algorithm. So the DSDV routing protocol is the one which comes under the proactive routing table routing protocol, and it works based on the distance vector algorithm. Routing protocol, we know that it provides a path for the source to the destination, so the information in order to reach in the networks to the destination. What are all the routing possibilities? That only we are seeing it now. So it is, as I told you earlier, it is the routing protocol. It is being the proactive table driven. Each node maintains the routing information for all known destinations. Routing information must be updated periodically, and traffic overhead even there is no change in the network topology. That is being the drawback of this. And maintains a route which are never used. It also these are all being the characteristics of DSDV routing protocol. Maintains the route which are never used. It also maintains the route which is, though it is not being used, some of the routes are being maintained. So it creates the flooding in the network. So but it is being very simple, low cost routing protocol algorithm. So it is always the route is being ready to broadcast the packet to the destination. So these are all being the advantages. And first one is again the continuation of the characteristics. This keeps the simplicity of the distance vector. It guarantees the loop freeness. It never new table entry for destination sequence number. It allows fast reaction to topology changes. Make immediate route advertisement on significant changes in routing table, but wait with advertising of unstable routes, damping fluctuations also. You can just see the table entries. The A, B, C, D are the destination nodes, and for the source for node A, you can imagine a network of 4 node scenario. For example, if A is the source node and destination node is also A, then what happens? So A is the node, the next node will be also A, the destination is A, and the metric will be 0. And if node is B, that is destination is B, you can just imagine the previous diagram of A, B, C, D nodes. We have A, B, C, D nodes. A, B is next to A and C is next to B, D is next to C. So like this, for example, for the algorithm explanation, we can just take the same example. So this is being the situation, we are writing the routing table thing. So A is the destination node for node A, and next node will be A, metric will be 0. If B is the destination, next node is B, and distance will be 1. If C is the destination and next node is B, and the distance will be 1 plus 2, that will be 3. And if D is being included, this 1 or 2 depends upon the cost, that is the number of hops being calculated automatically and updated in the routing table. So that is D is the destination node, the next node will be B. From A we are considering it. So the total number of hops required is 4. And sequence number is a number which is being automatically updated based on the link cost, that is the cost of the algorithm and activeness of the route. So installation time for the algorithm that is being done, and stable data for this is pointer A, B, C, D, like that. We are giving the routers. Sequence number is originated from the destination and ensures the loop freeness. Installation time is when entry was made. It is used to delete the stale entries from the table. Whenever the entry is made, the installation time will be done. A stable data is the pointer to a table holding the information on how stable route is used. Here it is used to damp fluctuations in the network. So advertisement of the route. Once the route is being found, how to advertise, how to make it clear to other destination nodes, other nodes. So that is the first thing is advertise to each neighbor own routing information. So for its neighbors, it indicates by destination address, number of hops, that is the metric, and destination sequence number. Rules to set sequence number information is on each advertisement. Upon receiving each of the advertisement, sequence number has to be increased. Use only even numbers. So even numbers will be used for the sequence numbers. If a node is no more reachable, if this time is being out, time out, or it takes no more time, and increase in the sequence number of this node will be done by odd sequence. Default, if the thing is going good, no problem in this, the sequence numbers upon receiving each of the advertisement, it will be updated by even number. If any of the time is not, if the destination is not found, or the packet is not being routed further, then immediately it will be sequence number will be updated by odd sequence, or the metric will be set to infinite. So it shows that that is not being that route should not be used for future reference. So route selection, update information is compared to own routing table. So after the update is being done, this is being compared to own routing table. Select the route with the highest destination sequence number. This is always the newest information. So based on the highest sequence number, we are selecting it. If the sequence number is being even, that is being valid, and the sequence number is being highest, then the route with the new highest sequence number and newest information, that will be selected first. Select the route with better metric when sequence numbers are not equal. So better metric is the cost. Based on the cost, you can select the route if the sequence number is not being updated, is not being satisfied. So A, B, C, 3 nodes we are taking it for reference, and as like the previous case, we are updating only with the sequence number. Only one table I will explain it. For the first table, blue colored, A is the node, source node, and A itself is being the destination node. The next node is E, and the metric will be 0. So metric is nothing but distance. And sequence number, for example, it is earlier versions, number of packets is being passed, and based on that, if it is A equal to 550, that is even number, it is a valid route. And for A node, B is the destination, the distance metric will be 1, and it is with a sequence number. For regarding the B node, through the B node, a number of entries done. So based on that, the sequence number will be given, it is B100. And if a C node, so next destination is C, and from the A node, next node will be B, and the metric will be 3. 1 plus 2, it is equal to 3, and it is done with a sequence number of even number. And similarly, it is done for A, B, and C. So with the different sequence numbers. Sequence number of C, last row only being updated, you can just see it. If it is going to the second table, second thing, B node, the entry for a sequence number for C alone is being changed by 586 to 588, next number, because it is the next node on the B. From B node, the packets are being passed to C, and it is the destination node. Next node itself is C, so it has to be updated for C entry. It has to be updated for 2 times. And similarly for the next thing, C in the C node, C to C, it is 0. It has to be maintained with the same last sequence number. It is not going to the next node. If it is going to the next node, it has to be updated by 560, but since it is being the destination, it itself is the node, so sequence number is maintained as the previous case. And route advertisement is done based on this. B increases the sequence number from that is what I told you. The routing advertisement is done by increasing the sequence number from 100 to 102, and B brokers the routing informations to neighbors. You can just see the table how 550 is there for A row, it is no change, and for B it is being updated from 100 to 102, and C it is 588. So B increases the sequence number from 100 to 102 and brokers this routing informations to neighbors A and C, including the destination sequence numbers. So once the information on new routes, broken links or metric changes, immediately it is propagated to the neighbors. And full update and incremental update, two types are there. All the routing informations from one table. Incremental update, it is send only the entries that are changed, rather than sending all the informations, only sending whatever it is changed. That is the incremental update. For example, insert entry D, sequence number D00, then immediately broadcast the one table. So you can just see the tables A, B, C. A and B with 104 entries, and C is with 590. It is being updated, and if D is the any new entry which is coming over here, that routing table is included with a D with a entry of all zeros. If it is a new entry, that sequence number, no other packets might have reached that node, so that entry will be 000. And for each of the case, that new node thing will be updated by increasing the sequence numbers. For the B node, the packets are being routed from D to B or B to D. It will be updated by the routing table will be updated by 592, and D is initiated by 000. Count to infinity problem, as like previous case, if any of the link is being broken, the immediate node that will be replaced by infinity. For D is C and D link is being broken, then for the C node it will be updated by infinity and not to the A and B. So that is about the thing. The advantages are just almost like distance vector, loop free, no latency, no sleeping nodes. Disadvantages is nodes are being restless, overhead, most routing informations overhead is informations are being more, so dumping the network. So we have seen something about the DSDV, distance vector routing protocol, and its basic characteristics and how the routing table routing updation is being done in this video. Thank you.